P0204 may point to a problem in the cylinder 4 injector control circuit on a 2015 to 2025 F150 with the 2.7 EcoBoost. That can show up as rough running, a misfire feel, poor power, a hard start, or a check engine light. The broad fault areas may include injector circuit wiring, connector or terminal issues, power feed problems, control side problems, or a command versus response issue. For this code, the diagnostic path here is general electrical setup and test logic. There are no cylinder 4 pinouts, component locations, or confirmed part replacements in this path, so do not guess those details. Start with the basic system checks and make sure the concern is actually present before making a repair call. Before you get deep into circuit testing, check for obvious concerns that match the customer symptom. Look for any available known issue or bulletin information, and check whether a previous repair was done incorrectly, because that can create the current problem. Verify the battery and charging system are operating correctly, and make sure battery SOC is greater than 70% before starting diagnostics. Then, scan all network modules for codes related to the concern. If other codes are present, handle circuit-related faults before system or performance-type faults. From there, inspect harness routing and damage, fuses, electrical circuits, connectors, component connections, vacuum and air intake leaks or restrictions, hose condition and routing, fuel quality, fuel system damage or leaks, coolant level and quality at correct engine temperature, oil level and quality, and exhaust damage or restrictions. When you connect test equipment or jumper wires at pins, use Rotunda Flex Probes NUD 105R025F or Terminal Probe Kit 418S035. The point is to test the circuit without spreading or damaging terminals. Check male to female terminal fit with the mating pin and feel for normal separation force. A damaged pin will have very low separation force. If a small pin cannot be checked correctly because the hard shell, pin guide, or retainer is adding drag, remove the pin as needed for the fit check. If connector, pin, or terminal damage is confirmed, replace the damaged connector, pin, or terminal. Use the scan tool to read PID input values, output states, and diagnostic states. Monitor the data in the data logger so you can test accurately before taking things apart. Make sure you understand how the module and circuit are supposed to operate and confirm programmable parameters are set correctly for the function you are checking. If a DTC is already giving you the proper starting point, resolve that fault first before moving deeper into functional testing. Then test the inputs, both hardwired and networked, and test the outputs. Also check for module software updates. If you use output state control and the module output works normally, that pushes the diagnostic direction back toward the inputs instead of assuming the output driver is the problem. For power-providing circuits carrying approximately 200 to 1000 milliamps, load the circuit with a 250 to 350 milliamp test light and measure voltage with a DMM while the load is connected. A voltage drop during loading points toward excessive circuit resistance. Small 24-gauge, 0.5 millimeters, or smaller conductors are generally used for approximately 1000 milliamps, 1 ampere or less, and a 250 to 350 milliamp test light is appropriate for those circuits. For circuits carrying more than 1 ampere, use a load that requires similar current, such as a brake light bulb. Larger 20-gauge, 0.8 millimeters, or larger conductors are generally used for 1 ampere, 1000 milliamps, or more. On higher current circuits, use voltage drop rather than relying only on resistance. For grounds, measure voltage drop during component operation or attempted operation. If you use an ohmmeter on ground circuits, disconnect the battery first. For most small diameter 18-gauge and smaller wires, expect less than 2 ohms. For most harness circuits, expect less than 2 ohms. Reverse the DMM leads during resistance testing. If the reading changes and there is no semiconductor in the circuit, the test result is invalid. To check for unintended continuity to ground, disconnect both ends and expect greater than 10,000 ohms to ground. To check for unintended continuity to another unpowered circuit, disconnect both ends of both circuits and expect greater than 10,000 ohms between them. To check for unintended continuity to a powered circuit, disconnect both ends, turn ignition, run power on, and expect no voltage on the suspect circuit. Back probing is only for situations where the circuit must be tested under actual operating conditions, or where voltage drop has to be measured with the circuit operating. It is not the right test for a single-point voltage check when 0 volts is a possible result, because you cannot tell a bad probe contact from a true 0-volt result. It is also not the right test for continuity or open circuit checks with an ohm meter between 2 points. In those cases, disconnect and isolate the circuit and test normally. When back probing is required, use proper back probes and do not force test leads or probes into connectors. For voltage drop testing, expect less than 5% of circuit operating voltage. If jumper wires are used, use fuse jumpers. The recommended universal testing jumper wire fuse is 5 amperes or less, unless the load requires a larger fuse. Use flex probes or equivalent to prevent terminal damage, but remember, flex probes are not intended to carry high current greater than 5 amperes. Do not apply power or ground directly to module-switched components unless a directed test calls for it. And do not repair a failed circuit by simply overlaying a new wire in parallel until the root cause is understood and the adjacent wiring has been checked. For voltage drop measurements, connect the voltmeter at the beginning and end of the suspect circuit. Then operate or attempt to operate the circuit with power available. Connect the leads following conventional current flow. A 0-volt reading usually means the meter connections are wrong or the component is not turned on. A small voltage reading is normal circuit loss. In 12-volt circuits, normal loss is usually less than half a volt, or less than 5% of circuit operating voltage. Voltage indications greater than half a volt indicate abnormal voltage loss from high resistance in wiring or connectors. For voltage in, voltage out testing, connect the negative meter lead to ground or battery negative. Operate or attempt to operate the circuit, and measure first on the power side of the load and then on the negative side. The power side should be within half a volt of battery voltage. The ground side should be greater than 0 volts but less than half a volt. A reading of 0 volts or source voltage indicates an open circuit. Keep verification separate from testing. After correcting a confirmed wiring, terminal, connector, or setup issue, operate the circuit again. Recheck the condition that set the fault and confirm P0204 stays gone. The main takeaway is simple. Do not jump straight to an injector or module call. Prove the circuit, protect the terminals, load test when needed, and let the voltage drop results guide the next move. For more diagnostic training, visit stepdiagnostics.com.